Hello, this is section 12.2, angles and angle measures. So our objectives for this section is to draw and find angles in standard position, and we're going to convert between degree measures and radian measures. Okay, so let's start with our vocabulary. So the first three words that we have are standard position, initial side, and terminal side. So an angle on the coordinate plane is in standard position if the vertex is at the origin and one ray is at the positive x-axis. So if you look at my drawing here, this is my angle from, here's the vertex at the origin, and you have one on the positive x-axis, so the angle goes this way. So this angle is in standard position. Now the ray, the part that is on the positive axis is called the initial side. The other ray is called the terminal side, and that's where the angle terminates. It stops right there. Okay, so that's the difference. It's initial side, terminal side. It's in standard position if it starts here and goes this direction. Okay, so if a measured angle is positive, the terminal side will be rotated counterclockwise. So look at this key concept box here. So we're saying right here, if the angle measured 120 degrees is positive, it starts here, the positive axis, and it goes counterclockwise 120 degrees. If it's negative, it starts here, the initial side, and goes clockwise. Okay, so let's draw an angle with a given measure in standard position. So we'll start with 215 degrees. So they want us to write 215 degrees and draw the angle. Well, I know that 215 degrees is equivalent to 180 plus 35. Why is that significant? Because I start here, this is my initial side, and I go, this is 90, 180, because a straight line means 180, and I need to go 35 more degrees, and there is 215 degrees. So all the way from here, it's 90 plus 35 gives me 135. All right, so the next one is negative 40 degrees. Okay, so we said when it's negative, we still start the initial side here on the positive x-axis, but because it's negative, we go clockwise 40 degrees. So remember, each quadrant is 90 degrees. So we're only going to go about this much, give or take, and that's negative 40 degrees. Okay. Now, and there's your example there. If you want to try the guided practice on your own, you can. Now, the terminal side of an angle can make more than one complete rotation. For example, a complete rotation of 360 plus 120 is going to equal 480. So here they start here, they go around 360 degrees, and then another 120. So we've rotated 480 degrees. So it's not limited to just 360 or less than 360 or degrees. One rotation is 360 degrees, and it can go more than one. Okay, so let's look at example 2. It says wakeboarding is a combination of surfing, skateboarding, snowboarding, and water skiing. One maneuver involves a 540-degree rotation in the air. Draw an angle in standard position that measures 540 degrees. So first of all, we know it's greater than 360, so we have to break it down. What does 540 equal? It equals 360 degrees plus 180 degrees. So draw my coordinate plane. So I start here, yes, and I go 360 degrees. Now I need to go another 180, so it's going to stop right there. So it starts here and goes around 360 plus another 120. So that is how you would draw 540 degrees. Okay, coterminals, this is important. It's one of your vocabulary. So a coterminal angle is when you have two or more angles in standard position with the same terminal side. So let's look at examples of what coterminal angles are. All right, so basically they're plus or minus 360 degrees. So an angle with the, so for instance, let's look at this angle here. So when we start here, and they go all the way around to here. Wait, let's start here. So they first do 60 degrees. That's going to be right here. So what we're doing here is we're starting here and we're going to draw a 60-degree angle. Yes? So it's going to be about right here. It's a little more than that, but that's close enough. Okay, so this is 60 degrees. Well then, what else do we know? So look at this. So then if we do 420, well 420, we have to break it down is what? 360 plus 60. So I'm going to start here and go 360 and then another 60. Don't I have the same terminal side? This is your terminal side. It's where the angle ends. Yes? And then if I do negative 300, well, let me do a different color. I'm going to start, let me do yellow. Bright orange. No, yellow. Okay, so I'm going to start here, and I'm going to go counterclockwise. So this is 180, 270, and I need to go 30 more degrees, right? So this is 60. Isn't this 30 degrees here? So guess what? I have the same terminal side for 420, negative 360, and 60 degrees. Okay, so that is what a coterminal angle is. So basically, in a nutshell, you're either going to add 360, multiples of 360, or subtract multiples of 360. So let's look at example 3. Find an angle with a positive measure and an angle with a negative measure that are coterminals with each angle. So they first give us 130 degrees. Okay, so first thing I'm going to do is I'm going to add 360, and I'm going to get 490 degrees. That's positive. Then I'm going to take 130, and I'm going to subtract 360, and I get negative 230 degrees. So I've got one positive and one negative. Now let's try negative 200 degrees. Okay, again, I'm going to add 360, which is going to give me negative 130, or 160, excuse me. And then when I subtract 360, I'm going to get negative 560. Oops, this is positive. So I have a positive and a negative just like they wanted. What if this was negative 420? Okay, so I'm going to add 360, and I'm going to get, and I want a negative and a positive. Well, that's going to give me what? Negative 60. If I subtract 360, it's going to give me negative 780, but they wanted a positive. So I'm going to have to add another 360. Remember, it can be any multiples of 360. So this becomes positive 300. So now I have my positive, and, oh, this is right, and my negative. Okay? So that was easy enough. So we've learned coterminal angles and standard position, and which way, if it's positive, it goes counterclockwise, and if it's negative, we go clockwise. Now we're going to convert, and we've talked about this. We've been doing degree measures, angles and degree measures. Now we're going to convert to radians. Okay, so 1 radian is the measure of an angle theta in standard position with a terminal side that intercepts an arc with the same length as the radius of the circle. So angles can be measured in units that are based on arc length. So, for instance, the circumference of a circle, a whole circle, is 2 pi r. So 1 complete revolution around a circle equals 2 pi radians. Since 2 pi radians equals what's in degrees, 360 degrees, degree measure and radian measures are related by the following equation. So 2 pi radians is equal to 360 degrees. If I just use algebra and divide this left side by 2 and the right side by 2, because I have a property that says I can do that, I just reduce to pi radians equal 180. So we have these two conversions, and we usually use pi radians equal 180. So to convert in your key concept box between, so let's look at this really quick here. So we're saying theta in radians, r is the radius, is also the same as this arc length here, r. Okay, so theta equal 1 radian. So if I want to convert from degrees to radians, I multiply by pi radians over 180, because if these are equal, doesn't this technically equal 1? Yes. If we want to go from radians to degrees, we flip it to its reciprocal and multiply by 180 over pi radians. So let's rewrite these. Let's do example 4. Okay, example 4 says rewrite the degree measure in radians and the radian measure in degrees. So if I want to take negative 30 degrees, and I'm going to multiply, I'm going to convert it to radians, so therefore I have to have pi in the numerator and 180 degrees in the denominator, because I want my degrees to cancel, and then my zeros cancel. Then I'm just using fraction rule, so I get negative pi over 6 is going to be my radians. Now if I want to convert 5 pi over 2 to degrees, I'm going to multiply by 180 degrees over pi radians. Okay, because I want my pi's to cancel and my radians to cancel. I'm going to simplify, and 5 times 9 is 450 degrees. See how easy that is? But the key here is you have to know your fraction rules, and you have to know how to multiply and know how to reduce. And you just basically know that pi equals 100, pi radians equal 180 degrees. So let's look at a summary of degrees and radians. This is called the unit circle, and you are going to have to multiply it. I mean, you're going to have to memorize it and learn it. You should get familiar with it now instead of next year. So they give you some common special angles, okay? They've got them in degrees, and they've converted to radians. So instead of memorizing this whole thing, there's a pattern here. So first of all, when it's here, it's 0 degrees. 90 degrees from here to here. And then this straight line all the way around is 180, 270, and 360. That's easy. So instead of memorizing, you can know 0 degrees and 0 radians are equal. Pi over 2, pi, 3 pi over 2, and 2 pi, 1 full revolution, 360 degrees. Or you just memorize the degrees and convert it to radians. That's what I do. Now the pattern is for this every quadrant, it goes the same way. So it's 30. There's 3 angles in here. It goes up 30 and then 15 between the two, and then 30 back to the main axis. And then again 30 degrees, 15, 15, 30. 30 degrees, 15, 15, 30. 30 degrees, 15, 15, 30. So instead of memorizing all of these, I just go, well, I know it goes up 30, and then there's 2 more. There's a total of 3 in between here, and it's 30, 45, 60, and then 90. Add 30, 15, 15, 30. 30, 15, 15, 30. 30, 15, 15, 30. And then you can, so if you knew that this is 225, but you didn't want to memorize the radians, some of you are good, some of you are, that's easy for you. For me, it's not. So if I want to do what is the radian degrees of 225 degrees, well then I just simply multiply by what? Pi over 180, and I simplify, and if you do the math right, you get 5 pi over 4 is the radian degree. So you don't have to memorize the whole circle, memorize the pattern, the first quadrant, and then you can figure out the rest based on the pattern. All right, we have one more example to cover. All right, and one more concept. So this is called another vocabulary, central angle. So of a circle is an angle with a vertex at the center of the circle. If you know the measure of the central angle and the radius of the circle, you can find the length of the arc that is intercepted by the angle. So when we're talking about the length of the intercepted arc, we're not talking about, so if this is 30 degrees, we know that this arc is also 30 degrees. Remember, the arcs have two measures. They have a degree measure and they have a unit length measure, which would be feet, inches, meters, kilometers, any of that, which is the radius. So in order to find it in length, you're going to take the radius times the central angle, and the central angle must be in radians. It cannot be in angles. Okay, so here's the key concept box, and it tells you for a circle with a radius r and a central angle theta in radians, the arc length s equals the product of r times theta. So here's your formula. Remember, you have to convert from degrees to radians before you can use that formula. So they want you to find the arc length. The monster truck tires have a radius of 33 inches. How far does the monster truck travel in feet just after 3/4 of a tire rotation? So let's write this out here. So we need a central angle. Well, all we know right now is that the radius is 33 inches. They want to know how far does it travel. So we know about 3/4 is about 3/4 of a circle, right? We can do it easily because it's a full circle. You divide by 4 and do it 3 parts. We want to draw it out. But if we didn't know that, so they gave us something like 3/15 of a circle, okay? So let's use that and figure out how to draw it. So we know it's 3/4 of a circle. So we know we need the central angle. So we know that theta is equal to 3/4 of 2 pi, because we have to be in radians to get theta. And we know that one full revolution all the way around is 2 pi, or 360 degrees, but because we need radians, we're going to use 2 pi. And we want to know 3/4 of that. So we multiply that, and we end up with theta is 3 pi over 2. Now we know r is 33 inches. Okay, they want to know how far did it travel, right? The arc length and length in feet. Well, we have our radiuses in inches, so let's start with how do we find S? So we're looking for S. So S is going to be 33 inches times 3 pi over 2. And then we have to convert inches, so we said 1 foot equals 1 foot equals 12 inches. So my inches cancel out. And then when I multiply all this out, I end up with S is approximately 13 feet. Okay, so you had a couple things you had to understand. You had to figure out what your theta was, but you need theta in radians. So it has to be in terms of pi. And we knew they said it rotated 3/4 of a tire, which is 3/4 of a circle, so 3/4 of 2 pi. And there you got your theta. Then we knew what r was, is 33 inches, but they wanted it in feet, so we had to convert that to feet. And so it traveled about 13 feet after 3/4 of a tire rotation. All right, do the practice problems, and we'll see you in class.